Hello, everybody, and welcome to the Dark Reading News Desk from Black Hat USA 2025. We are thrilled to welcome Colin Estep, Principal Engineer at Netskope, and Dagmawi.
Yep.
Did I get it? All
You got
right,
it right.
excellent. Mulugeta.
Mulugeta, yes.
Mulugeta.
Close.
Okay, great. Sorry about that. Thank
No,
you.
it's-
He's a staff threat research engineer at Netskope as well. And here they're going to give us some insight into this really exciting research. Your traffic doesn't lie, unmasking supply chain attacks via application behavior. This is really exciting. I mean, reading through it, it felt really exciting. We are at a time now where every CEO is actively thinking about supply chain security in a way that they hadn't before. And you all have a novel new approach. Can you tell us about it?
Sure. So yeah, I could take the first swing at this.
Yeah.
So yeah, basically what we're doing is we're bringing Netskope's data to bear for the community. So basically we have a ton of data from our customers on their network traffic, essentially. And so it's rare that any particular organization has that kind of data.
That kind of view of the whole.
Right. A big view of all different industries, companies all over the world,
Yeah.
and how they're using applications. And so we're able to analyze some of that and use it to try to detect supply chain attacks. So it's basically, instead of just looking at code and CI/CD pipelines, we're looking at, once it's been deployed, how is it behaving?
So what does that really mean? I mean, we've been talking about S-bombs and all these different approaches. This seems like a much more straightforward one. I mean, what is the opportunity to really scale this sort of approach?
Yeah, and so when we first started this project,
Yeah.
we were thinking about where does this really fit in, like Colin mentioned, and we found that we actually really want to identify it as far right as we can when the application is being run in customers' environments. We want to be able to capture these applications' behavior and identify any anomalies. So when we want to scale this up, it's really as simple as the more applications we're able to model, the more we can identify any anomalous behavior that's happening. And like Colin mentioned, we have access to quite a lot of data. And with that data, we'd like to think we also have the responsibility for the cyber community to keep it safe. And that's why we open sourced a lot of our insights to share with the community of how to make this better by scaling it up ourselves, adding more applications, but also bringing in people from the community to share their insights and their data as well.
So if I'm a cyber professional in a business and I want to use your open source, your tool is open source and available, right?
Correct.
If I want to, what is that experience going to be like? How is that going to work in an individual environment?
Yeah, so basically they can just download the software from our repo, and a lot of the dependencies that we use are in containers. So it's really trivial to kind of stand it up and start using it. And we use some really universal sort of network traffic capture formats that we use as input. So PCAP files and HAR files, we support that. We also are using something called Zeek, which is another open source project that takes telemetry from network captures and puts it into another format. And so if people are already using Zeek, they can also sort of take the results from that and put it into the tool.
So not a heavy lift.
Not
Not at all.
Yeah.
Why the application layer? Why is that important, and why is anomalous traffic there more important to look at than other places?
So what we noticed that we started looking at this data is no matter where the supply chain compromise is in the software development lifecycle, it always ends up being anomalous behavior when the application is being run.
Right.
So that always ends up being kind of the place you want to have the control. Yes, it's important to have it shift left and identify it early. We definitely agree with that too, but you absolutely want to control at the end when the application is being run too. So we thought that would be the unit, the scale that we want to use is when these applications are kind of behaving anomalously. And that's why we chose the application.
And what kind of anomalous behaviors sort of make the cut? You know, what is the anomaly? What is sort of the Mendoza line of this is anomalous but not maybe catastrophic? But you know, I guess how are you combining insights with the anomalous behavior?
Right. So we have quite a few features that we sort of designated in the modeling. So it's like 185 features or so
Close to 200,
that
yeah.
Wow.
we pull out, and It looks at things that like the timing of things, size, bytes, all these different statistics that it gathers. And then it kind of decides based on the application's normal behavior what's important. So like if you have a file sharing app, the amount of bytes you're transferring and things like that actually become a bit more important in determining if this is really an anomaly than if, say, you were using some other like Slack or something like that, where the sizes might vary a little bit more often there. So it varies from app to app, which is why we kind of model them by app.
Yeah.
And then in the features themselves, we give you the odds that this is an anomaly, and then overall it computes, okay, based on all these odds, there's a 99% probability that this is an anomaly. And you can look at the features for yourself and see what it ranked and how it ranked them, and then you can make a decision from there.
So essentially, the tool is going to give us a ranking order of what is the protocol believes is most important, and then you can sort of take a human eye to that and sort
Right.
of.
Correct. Yeah.
Okay, so does this approach, I mean, do you foresee this being sort of the next wave of supply chain attack? Do you feel like this is something that could scale to ultimately make an SBOM obsolete, to make a lot of these things obsolete in a lot of instances?
So we don't necessarily see making them obsolete, but we see them pairing together. We will see the traditional controls like SBOMs, CI/CD controls like Colin mentioned, also running, but then this works kind of at the last stage as well. So if for some reason any of these controls fail, you still have another control at the end to be able to identify when an application is being anomalous.
As far right.
As far right as
Okay.
possible. And to add on to what Colin said earlier, these features that we extracted, we actually, started off by looking at past incidents to see what would have identified this incident if we had that feature or that signal in place. So we use signals that would have detected these incidents, built up the modeling that way, and have it as kind of a fail-safe towards the far right.
Interesting. And is there a place for this data in the development pipeline? I mean, is there do you envision an opportunity where then these things go back to the developer to then do updates for this, like to update their own apps, or is this mostly just how it's being used in your own individual environment? Or do we know?
Yeah, I don't really foresee it kind of providing feedback back to the developer, but I could see how people who are operating, like network operators and security operators in various environments might find this useful even just for inventory purposes to say, hey, it turns out I didn't think we had people using Microsoft Teams, but we do, or
Like
something
an
like that.
application inventory.
Yes.
Exactly.
Yeah.
Are there other tools that do that? I don't know that I've heard about application inventory tools.
Yeah, there's been some. I'm not super aware of anything that stands out either, but I have heard of this before, and I've certainly had colleagues that have come to me and said, we're having trouble figuring out even what we're seeing in our traffic. Like how do we inventory what's being used and where? So
Well, I mean, even in our own personal environments, it's like I downloaded an app to get into a thing in another state 5 years ago,
Right.
and I can't imagine on an enterprise scale how much that can.
Exactly.
can-
Imagine like 10,000 users. That's quite a
Right.
problem. Yeah.
So, are there active users on this right now, and are you getting feedback from them about its efficacy, sort of in real life?
no, because we just open sourced it today.
Yeah.
So yeah.
Today's the launch.
Yeah, so we just launched it today with our talk. So we haven't had it publicly accessible. Black Hat loves new stuff, so
Yes.
we wanted to kind of keep it under wraps until now.
That's very cool. And
Yeah.
thank you for giving us a little scoop here, too.
Sure.
Can you tell our audience where they can find out more, and more importantly, where they can access your open source tool?
Sure. So on GitHub, you can look at the Netskope OSS repo, the Netskope open source projects on GitHub. You'll see Beam there. So and we also have a blog that was posted today. So the Netskope Threat Labs blog will also point you to everything and give you an overview of the tool.
Thank you so much for coming here and sharing. You've given me really a lot to think about. I think this is such an interesting twist on this problem that everybody's been kind of banging their heads against the wall to try to figure out. So thank you so much. I really appreciate it.
Oh, thank you.
Yes,
Thank
of
you for
course.
sharing this,
This has been a conversation live from Black Hat USA 2025 at the Dark Reading News Desk. Thanks so much for joining us.